Hello everyone, September 22nd. Yeah, yesterday was pretty bad. We didn't solve this basically. We got a timeout. I didn't read the official solution. I copy and paste, just get the yesterday pass. I have some idea, so I probably would try if I have time today. But today was quite crazy because I need to share some photos, about 790 photos. Okay, so I upload them to Google Drive, Google Photos, right? And when I got the photos are all well organized. They have file names which are ordered from 1 to 790 something, and they also have well organized. Not really well because they're all taken by professional photographers, and there are correct created time, right? So they have a timestamp for all of them. So in my mind, if I upload it to Google Photos, they shall be properly sorted based on either the order of the file name or the order of when they're taken. So I uploaded it to Google Photos, but lo and behold, it was not sorted the way I wanted. It was not random sorted, I'm pretty sure, but it has a very weird way of sorting it. I couldn't figure out how it was sorted. For one thing, it does not allow sorting by file name, which I figure probably due to some distributed computing requirement, which is fine. And it does allow you to sort by recently added, right? Newest first, oldest first. Yeah, that's all good. But I have all the photos with the created time, right, in order. But when I sort it by either latest, newest first, older first, it's still not according to the order of the created time of all the photos. And that got me really, really frustrated. And a search online, it was not a consensus of exactly how Google sorts its photos. So I just tried, I tried. So online there are tools that can modify a photo, an image, created time, like that specific metadata. So it's called EXIF tool. So I use that. I change some of the photo's time. By change it means just shift it. Just shift it to some time later, right? So on Google Photos, I have one photo get sorted really early, but actually it's taken much later. So I took that photo, I just shifted it forward, right? I just shifted forward, and after I shift it forward, it does get sorted later. So that is probably how Google sorts its photos based on this created time metadata. So yeah, and then just write a script. I grab all the photo files and just shift them forward by some amount of time, and I have to make sure that the photo that's been taken later will be shifted forward further compared to previous ones. So just a little bit of logic in there, and then we were able to shift all the time of 700 photos to however we wanted, and then we upload it to Google Photo, and yep, lo and behold, now it's sorted the way we want, right? Perfect. And then Google was done, but Google was blocked in China. So if I want to share it with somebody in China, I couldn't use Google. So I have to use a different cloud, and I have no idea what cloud can be used. I asked around, and people say Apple's iCloud. iCloud is accessible in China. So I upload the photos to, also try to figure out how can I upload. First, I just upload it to Photos, but then even if I created a temporary link, the people in China who actually they don't have an Apple ID, so they couldn't open it. So I have to create a shared album. So I create a shared album. I put the photos in it, and I created a public URL, and yeah, it works. The people in China, they can access it very good. But the photos order gets randomly sorted again. It's like they have a different way of sorting photos, and this is just madness, right? This is just madness. How could and you cannot sort it like custom sorted. Like how difficult would it be just to sort the photos based on something in the metadata? Like my photos have good file names. All of them have very good file names, right? Ordered file names. They have well ordered. I just did it myself. Well ordered created time, but still it's not sorted. And I look online to see like why the shared album on Apple is not sorting the photos the way I want. And turns out the shared album itself is not an album. It was a different service, just renamed into shared album. The previous name is shared stream. So that service, right? That you can see that it's called an album, but it's not an album. It's just a stream, which means the photos gets added in the order of when you upload them. Okay, and of course, when you upload the photos, it doesn't mean that it will be added exactly the order you upload them, because when you upload it, I'm pretty sure it's distributed, right? It goes through multiple threads, and then it's distributed writing into Apple's cloud. So the first, I mean, if you upload 10 photos, right, the first photo is not guaranteed to arrive there first, and on the stream, first come first served. So yeah, that's why when I upload all 790 photos, just the order is completely bonkers. So at the end, I mean, of course, if I upload the photos one by one, yeah, it will be in the order because it's a stream, right? It's a stream. I upload one by one, it will follow this order. But that's 790, right? Even if I do 1 second, 1 photo per second, that's 790 seconds. Okay, that's like more than 10 minutes of uploading photos. And I'm not gonna do that. So I just batch it like 20 photos at a time. So within the 20 photos, the order, yeah, I just don't care about the orders within 20 photos. They might be shifted around, but it's okay. Overall, like you divided 790 to 20 a batch. So overall, the order still works. So that's how it's kind of getting resolved at the end. So man, this was, I mean, it was not really hard work, but it's just very exhausting. You know, you thought that all these big companies they will figure it out. Like this is just a simple use case, but I'm also pretty sure they have a good reason not supporting the service that we want, like sort by file name. There is a good use case. I'm pretty sure, but still, it's frustrating. Very very frustrating. Uh, all right. Yeah, let's just do today's. Let's see what we have today. Hold on, I have some other things just coming up. All right, I might have to like just pause, but I'm like responding to some other stuff. All right, let's just do this. Hopefully today we can do it. I mean, apparently I did it before, so it should be fine. What is this? Zero index a string, dictionary of words. You have to break S into one or more non-overlapping substrings such that each substring is present in dictionary. There may be some extra characters in S which are not present in any of the substrings. Return the minimum number of extra substrings left over if you break up as optimally. So we will break it up. One or more non-overlapping substrings such that each substring is present in the dictionary. Each substring is present. So that each substring is present in dictionary, so it doesn't really matter. So as long as it's in it. And then there may be some extra characters. Return the minimum number of extra characters left over if you break up. So we'll break up this optimally, and then there'll be something left over, and we'll hope that there will be minimum number left over. Okay, what do you think? So we have a dictionary, right? And we need to break it up in non-overlapping fashion. So which means we have to go through this. I mean, maybe we can build a try based on this, right? Let's say we build a try based on this, and then we just start going. And every time we hit a word, we just recursive for this, right? We recursive for this, and what do we return? We return the number of characters that's not included, right? So in this case, okay, LEET, and then we found a word, and then we just pass from this to the end. We try to break it up, and then yeah, and then we check the next one. It doesn't belong to anything, so we cannot do it, right? So yeah, so this one hopefully will return a number, right? And then now it's starting from this, so we're trying to see, maybe we can even cache it. Right, you start from this to the end, what is, yeah. So we say we start from S, and it doesn't belong. So I skip forward. So now that's 1, right? So COD, good. So now this one will return. So COD, CO is, so once we have something that does not fit, we'll just call the next one. And it fits. So I'll call the next one, and we'll return 0. So we'll return 0, that will return 1. Okay. So here the same. So we try to do S, nothing, A, nothing, Y, nothing. H, so this will return 1, right? This will return 2, return 3. Okay, so I think a try shall work. Do we need to? Yeah, that's the thing. Do we need to? Yeah, let's create a. Let's create. Let's create. Memo. Okay. This.memo new s.length. Okay. Probably use this multiple times. I just do this s.length. Okay. So this memo is the number returns, right? The number extra, right? The number extra. Now we want to find the extra of this. Okay, and then we're gonna say private int dp. We need index, we need string, and we need a try. So we need a try node. Okay, so try class try node. So we have a character, a Boolean value. Okay, no, not Boolean value. We have a string. Should we need a string? We don't need a string. We can just set a Boolean value. Is word. Okay, and then we have a map, right, of character, and each one would type to a new try node. We'll call it children. Okay, try node. Okay, and then try node. This is going to be character char C, right? So this is create. So this dot. Actually, no. We'll handle it manually. I'm gonna say this dot children goes new hash map. That this we can do, right? And yeah, it's I guess it's fine. We just we just do this. It's okay, right? Let's just do this. Okay, so we need to build a try node first. But anyway, so here we need, say, try node root. Okay, so I'm gonna build a try. How do we build a try? From the dictionary, right? So we can say try node root new try node. Oh. Root. Okay. And then for string dict of dictionary try node equal to root for char C of dict dot char array. Node dot children dot put if absent C new try node, right? And then node equal to node dot children dot get C. And the next one. Once we're done, the last one node will become this, and then we say node dot is word equal to true. And in fact, we can say is word equal to false, right? Okay, so that's to get the try. Now once we have the try done, we can basically just say return dp 0, right? So we say from 0 s and then root. Now we need to figure this out. Actually this only uses 1, so we actually don't need it. Index if index is equal to s.length, right? Or we can, yeah, if it's equal to index.length, then we'll return 0. And if we need to go memo arrays.fill this.memo -1. Okay. And if memo index is large equal to 0, return memo index. Now otherwise index, well, we set it to 0, right? Yeah, and then we'll have just from the index, we need to go through the root, right? We'll go through the root, and we will have okay, so actually this shouldn't be this. This should be integer dot max, because we want to find a minimum. Right, and then let's say count. Removed, right? All right, so try node equal to root, right? And then we can say if it's while, so we should say while node dot children while s dot char at. Okay, node dot children dot contains key s dot char at index, right? While dot contains, now we say node equal to node dot children dot get s dot char at index. Okay, we move there, and then we'll say if node dot is word, then we say mammal index shall equal to math dot minimum count removed. No, minimum mammal index removed plus dp. Let's say index plus 1, right? Index plus 1, because we go for the current one, and we hit the node, and it's a word, right? It's a word. So we go to the next one, and s and a root, right? So this if node is word, so we do this, right? But doesn't matter. Does not matter. We always do index plus plus, right? We index move to the next one. Right, if it's not word, it's okay. So we go to the next one. Try to see if it is. If it is, we just do this. All right. If it is, then why do you use removed? What's the purpose of removed? Because if you see one, you always just go for the next one, right? Yeah, you just check. Right, check. We have a what are we just gonna do? Yeah, I don't think we need this one. The remove is not necessary, so just do that, right? And index plus plus, and move on. We will do it again, right? And move on until at a certain point, either index, so index is smaller than s dot length, and node dot children contains key, right? So we're gonna node, we check this, blah blah blah. At the end, it will get out, right? It'll get out if index is smaller than s dot length. No, we just, when it gets out, we have to check if Yep. So we say if index is smaller than star length, so which means it's because something is bad, right? Something is bad, then memo index shall equal to math.minimal memo index and 1 plus dp index plus 1 as root. Right. This is just within, because you can have many choices, right? You can have many choices. You go here, you can say, oh, if we hit, then we break there, right? Or we can also keep going on, right? We keep going on. But if we hit the first one that cause it to break, then immediately we go for the next one, right? We go for the next one. So once it's all done, and of course, if it gets out because it's equal to the length, that means we're already done. Now we just return memo index. You don't have to do this. We can fill it with integer.maxValue, right? And then we can check if it's smaller than integer.maxValue. Okay, let's give this a shot. See if it works. Yeah, just use this or run it. Next out of range. Ooh, okay. Yeah, that makes sense. I'm changing index directly. That's not right. I equal to index. So all the index shall be turned into I. Yeah, this is I. Nope. This is not I. This is not I. This is I. This is I. This is I. These are not. This is I. Okay. Let's try this one. Looks good on this one. Let's try the other one. Oh. Looks alright. Maybe this is the solution. Maybe we'll slug it out. 2707. Build a try out of the dictionary, and then break up S at each possible match, possible substring match to the try, right? We can use dp to memorize some of the intermediate results. So build a try, it's called an OM, right? And I think it's each one you have to go down. Yeah, so this index will call OM times, right? And each one you might have to go down every single time. So I'm gonna call it O m plus n squared. That's my guess. Like m is where M is the total number of chars in dictionary, and N is the length of S. Okay, that's why. I think I may get a few more test cases. Let's say we have LeetCode, right? That should be pretty good. Let's say we have I don't know, just throw something in there. Looks all right. Let's try it. 2023 was the previous time. Ah, Lord. I knew it. And it's probably this. So instead of int max, I don't know, let's just pick a number. I don't know why it will be like this. So we cannot do the integer maximum. Yeah, the length is 50. The max is 50, so we can just do 100. So I can just do max, and I can just do max. I can do like 1000. It's for more safety. All right, that is not right. That is not right. Okay, something is wrong. Something is wrong, very wrong. Should be 7. Huh. Let's take a look at what happened here. Basically, it did not make any change. Very strange. Let's say system.print.out line. Let's say arrays string this.memo. Okay, so for one thing, I should say this.memo for every single time, just for consistency. Okay, let's just see at the end. Okay, nothing gets updated. That is very strange. That is very strange. I have a WMO, right? How's WMO not getting? Maybe I shouldn't do this. I think maybe at the end I should do this as well. It doesn't matter if I is smaller than. If it gets out, it does. It does. Oh, hold on. Let me think again. All right, so we get out. If it goes to the end, right? If it goes to the end, then we shall do here, right? So maybe this is where we should say is I is smaller than s dot length. If it is, then that's a mismatch. Otherwise, it's a match. Then we can do this. Which means, let's try this one. What might happen is at the end it was a match. It was a match, but it didn't match everything. Hold on, let me think again. So it doesn't match, so we try the next one, right? It doesn't contain, so we say 1 plus the next one, 1 plus the next one, 1 plus the next one, and at the end, right, when it gets out, it could either be I hit the end, or it could be like if I is smaller than the length, then we have this, right? So if I is equal to the length, how would I equal to the length? W, right? It's a W. So we hit this match, and then it gets out, right? And then it gets out. So it's equal to the length. So what is important is when it gets out, if it's a word, right? If it's a word. If when it gets out, it is a word, then we just, yeah, if it gets out, right, because inside I already did, I say if it's a word, a current node, right? So I plus plus, so node goes to the next one, I plus plus, so they get out. So they get out, if it's a word, then I already handled it, right? So if it's not a word, then so basically here we say if not node dot is a word. If node is not a word, that means it's a mismatch, right? That means it's a mismatch. I need to count. Yes, so we are hitting, and boom, we get out. Right, we hit the last one. So, ooh, it's not a word. I need to count. I need to count the length of the word. Because those are all... So it depends, right? It depends. So no, it's contains no move to the next one, I plus plus, right, and then get out. And when I get out, if it doesn't match, okay, so if I is equal to s dot length, right, that means it's a match. Then we need to find something else. Alright, so what we're saying is I need to this dot word, this dot length. Oh, but the length, it depends on which word it is. Right? It depends on which word it is. No, the length is, so this dot length. Okay, so when we do this, okay, say int I equal to 0. Say node dot length I plus plus equal to I plus plus, right? Okay, now we have no dot length. So when it gets out, yeah, we can say if I is smaller than s dot length, right? That means we must be a mismatch, right? Which means we find a mismatch. So we go, boom, we find a mismatch. Oh, it doesn't matter if I find a mismatch or not a mismatch. What happens is we have a something, like we match the first something and then something is a mismatch, right? And then this whole thing cannot be part. Wait, hold on, really? Yeah, because what we're saying is every time we'll hit a word, then we'll go, right? So we hit a word, then we'll do this, or we keep going. But if we keep going, we hit something that's bad, right? If we hit something that's bad, then we have to remove this whole thing. Right? If we hit something that's bad, we have to remove the whole thing. Right? If we hit something bad, we have to remove the whole thing. Because we're trying to do this. So we have to remove this whole thing and then we try to do the remainder. Which means when it comes out, right? When it comes out, either we go to the end or when it comes out, what we need to know is what is the current stretch. what is the current stretch? Right, if it contains a key, if it doesn't contain a key, yeah, then the whole stretch needs to be removed. Yeah, so the whole stretch needs to be removed. It does not matter. So which means if it gets out, whole stretch needs to be, which means it's just going to be I minus index. Index is the start. I is the current that gets bad. So I minus index is the previous stretch that need to be removed. Okay, so if we try this one, this dot len. Actually, I don't think we need this dot len. We didn't even use it. Alright, we didn't use it. What the hell? Yeah, because I is already at the end, so we can say if it's larger or equal to. All right. This is also not right. Wait, where did I got it wrong? I said I create a try. I think the try is right. And then I start go through this. Right? I start go through this. And I have I is starting with index and I check, right, if it's in it. If it's not in it, it's not in it. Like if I equal to 0, right, and it's not in it, then when we get out, index is 0, that becomes 0. It should be I minus index plus 1, right, because it would include the current. But if, yeah, it depends. So maybe what we can do is we say if, because if I go to the end, right, if I is equal to I plus plus, so I is equal to s dot len, so we have the final stretch in, right, the final stretch in. If that's I at the end, if the final stretch is part of it, then we already have it, right, and then we do I plus plus. But if it's not, it gets out, right, then I need to retrack I back. Then I can do I minus index plus 1. So I say if I is equal to s dot len, okay, and then we say I minus retrack, and then I can do this plus 1. Is this right? Oh my god. It's basically trial and error. And it was still not right. Huh? Why in the world? Exactly, what in the world? Well, for one thing, oh, of course. Damn, of course it's not hitting anything. We need to call this first and then return stop mammal 0. I am 7 here, so if you start from D and start from W, it got 1000. I mean, for one thing, we start from D, right? We hit something, and then we got a W, and we got knocked out, right? We got W, we got knocked out because there's no DW. Okay, there's no DW, so we got W, we got knocked out, and in that case, so D is in, W when it gets out. Okay, so I is not equal to this, so basically we're saying we'll get DW out and then do the remainder. So that is not true, right? That is not true. So what we should do is at each one, right? If, yeah, I feel like this is not right. I feel I need to redo this. I think the idea should be we just go 1, right? So we say we either break here or we don't break here, right? We either break here or we don't break here. So what I'm saying is, if it doesn't, right? If, let's say, so if we don't break here, so we need to move on, right? We need to move on. But if we break, so each one we can choose to break here or not break here. So I think we need to say try node, maybe a node, right? And each time what we're doing is split here. Okay, we'll split here. So it depends, right? We split here, so it depends. Then we say this dot memo index equal to math dot minimum, this dot memo index. So if we split here, then we should be this plus dp index plus 1 as root and a root, right? If we split here, then we have to start from the root. And here is if node dot children, right? If we split here, if node dot children dot contains key s dot char at index, right? So if it contains this, like the current one is part of it, and it contains this, and it's the end of the word, right? So we say if it's the end of the word, then it will be 0, right? Otherwise you need to add 1. That is if we split here, or we can choose not to split here, right? We can choose not to split here. If we choose not to split here, then we just move on to the next one. Split here, so we have a boolean value is end of word. We know that children dot contains key s dot char at index, and So node dot children, right? Dot contains. So node child. So this node can lead to s, right? And then after lead to s, go to the next one. It's the end of the word, so we can split here, right? And node dot children dot get s dot char@. So why don't we just go, let's say char c s dot char@ index. Okay, so here we can say c and dot get c dot is word. Okay, is end of word. So what we can do here is we say is end of word. If it is end of the word, then we do 0. Otherwise, if it's not end of the word, then it's 1. Right? This one we have the split. Right? We have the split. Then dp go to the next one. Right? We just split here. If it's end of the word, it's if the current is end of the word, we split. Right? Which is fine. We don't encounter anything. If it's not end of the word, then this current character need to be counted. So that's one. Try not to split. Right? So when you try not to split, we'll say if node.children.contains key c, right? Try not to split. So if it contains the c, then we do not split. We'll say this.memo index equal to math.minimum this.memo index, right? Will be that, and we continue. So the current does not get any because it's a match, right? It's a match. Then we move on to the next one, right? So it's a match. Then we move on to the next one. But this is also not right because right? How is this gonna be right? So we either split or we don't split. It's like if we can afford not to split, then we just keep moving. But what if at a certain point we have to split? And you're only counting the current word, right? You're not counting no. It should be, yeah, I guess there's no point. It should be you're at this point, right? You keep moving forward, right? If you can split, you split. If you cannot split, then this whole chunk is going to be yeah, it should be we split here, right? We split here, and then we'll choose not to split here, so we will keep moving forward, right? We'll keep moving forward, which means we'll have int I equal to index. Keep going. If it's a word, then we run this. Then why you need this node? think this is just going to be root. Because each time you say, we're going to split here, right? We add this, we're going to split here, and basically we'll check if it's the end of the word. If it can be end of the word, then we will, but it doesn't matter, right? It doesn't matter. We just say we delete this and then we want to go forward. Yeah, actually it doesn't matter. I think I can just say, this, right? We just split here. Doesn't matter. We just split here and then we move on. Or we can try not to split, right? And then we'll have try node. Right, try node equal to root. And then we'll try to say if node of children, if it's good, we just move on. I++, keep going, keep going, keep going, keep going until we hit a word, we split there. Right, we hit a word, we will split there. Right, and it's also possible that we get out, but we get out, it doesn't really matter. Right, it doesn't really matter. Yeah, we don't have to do any of this. I think this should be fine. Right, this should be fine, and this will need it. Okay, let's try this. Oh, I didn't realize this one took so long. How about this one? Yep, this one looks right. Can we put everything back? Yes, try it. Okay, I think this one's right. And the runtime. Okay, so we're gonna return here. Yeah, basically just we need to split here or we try not to split. Right, and since we already split here, so we just, this is handle the splitting part. We don't have to handle anything else. And let's submit it. Yep. Oh, it take too long, man. It's like an hour again. When the goal is every night we spend half an hour on this. And we always just go so wrong. It does not have the other one. Oh, it does. Look, this is split here. Yeah, we don't need this. We can 1 plus, yes. Very straightforward. Right, split here or not split here. And I use a trinode to do this, which can be a little bit faster. Okay, yeah, that would be it. I don't know. I mean, I'm definitely in a funk these days and not doing very well. I'll see you guys tomorrow. Adios.